Right, so today we resume our lecture. So just to recap what we have learned previously, we are still in LU3, which is one-way ANOVA. And in our first lecture, we have talked about how to do the ANOVA test. And first thing first, you have to know what is ANOVA and why you use ANOVA and not t-test. It is actually a continuation from LU2. In LU2, we are just dealing with 2 samples, but in ANOVA, we are dealing more than 2 samples. Okay, so in reality, later in your research, you are going to deal with a lot of samples. It's not just 2 samples. So that's why you have to know what is ANOVA and how to use it. For ANOVA, we deal with at least 3 samples, and it could be more. Yeah? It could be 4, 5, and so on. It's more than 2 samples, the rule. Okay, so one-way ANOVA, I think we go through the steps before. We have to, it's the same. We set the hypothesis. We want to know whether there are a difference in all the samples that we are analyzing, right? And the alternative says that there is a difference. Null hypothesis says there is no difference, and you have to create the ANOVA table. Yeah, I'm just trying to recap what we have discussed before for ANOVA, and then you have to find what all these SST, the sum of errors, and the sum of squares for the treatment, the sum of squares for the error, and you have to determine the F calculated, and you have to find out the F from the table. You compare both values and you make a decision whether you accept the null or you accept the alternative hypothesis. Okay, so that is ANOVA alone. So last week we have talked about post-hoc test, whereby we do this test whenever we find a difference in the samples that we are analyzing, or in other words, we accept the alternative hypothesis, which means that there is a difference. Okay, so we do the post-hoc test in order to know where the difference lie. Yeah, where the difference lie, where is the difference? Because now we have at least three samples, and in the ANOVA test before, we have concluded that there is a difference, but we need to find out where is the difference. If we have 2 samples, like in t-test, we don't have any problems because we only have A and B. So if we conclude the alternative hypothesis, obviously we know that there is a difference between A and B, right? But if we are dealing with more than 2 samples, like 3 or more, if we say that there is a difference in the 3 samples, so where is the difference? We need to know. So that's why we do the post-hoc test, okay? Right, so this is what we have learned last week. I just go through briefly because our topic today is a continuation of last week's topic, right? So there are altogether 4 tests, 4 types of post-hoc tests, which is least significant difference, LSD, okay? But we're not going to focus on the first 2 tests that really much, because we're going to focus more on Tukey and Bonferonni methods, which are the last 2. Okay, so this is just for you to know. The second test is a Shepherd test, right? So these 2 tests are not that really preferred because they have some drawbacks or weaknesses. So that's why Tukey test and Bonferrini test are preferred. Okay, so last week we talked about Tukey test. Tukey test, one of the important criterion that you have to know is that this test is used when the sample sizes are equal. Okay, so what is meant by the sample sizes? The sample sizes here is the size of the samples. If you have 3 samples, right, and each of these has replicates. Yeah, every of the samples have like its own number of data, where it is actually known as replicates, replication, right? So each of these, it has the sample size, we call it. So if the sample sizes are equal, let's say the sample 1, 2, and 3, each of them has sample size like maybe five, yeah, five data, it means five replicates. So it has equal sample size. But if let's say one of them doesn't have five, let's say four, so we can say that in this situation, the sample size are not equal. So a Tukey test will not be used for this situation when there is a difference in the sample size, okay? So you have to know that Tukey test is only used when the sample size is equal. Right, so okay, the last method is Bonferonni method. So what is the difference between Bonferonni method and Tukey method is Bonferonni can be used whether the sample size are equal or unequal. Okay, so it means that Bonferonni it has more applications actually. It can be used for both situation. But please take note of the second statement here. If sample sizes are equal, the Tukey method is superior to the Bonferonni method. Okay, so if you are, if you come across a situation where the sample size are equal, even though you can use Bonferonni, you can use Tukey method, but you have to know that Tukey method is much better in that situation compared to Bonferonni. Okay. So if let's say in the question it is not mentioned which test you have to use, I would suggest you to use Tukey method. But if you use Bonferonni method, also it is not wrong. It can be used, but it's just that it is said by it is stated by the statistician that Tukey method is more superior than Bonferonni method in the case of where the sample size are equal. Okay, but if let's say the sample size are not equal, then you don't have any choice. You have to use Bonferonni method. Okay, so that is Bonferonni method. And last week we have talked about Tukey test in detail. What are the steps, right? So basically, both of Tukey test and Bonferonni test, they are continuation of the ANOVA steps. ANOVA steps that we have talked before. Okay, when you have to generate the ANOVA table, you have to calculate the SST, TSS, and so on. Okay, so Tukey test and Bonferonni are performed if, let's say, your decision is to accept the alternative hypothesis, right? Okay, so it means that it is a continuation. So how you want to do the Tukey test is after you do the ANOVA test. This is what is meant by the first step here for the Tukey test. I just go through the steps again, yeah? So you will start somewhere here in the second step, yeah? Whereby you have to calculate the critical point for Tukey. So this is the formula for critical point, the whole thing here. So where you have to identify what is Q. Q is the critical value at the alpha level for the studentized range distribution. Okay, so for Tukey test, you have to refer to a table called studentized range distribution table, right? So it will be given in the exam, but you have to know this table is for Tukey test. And you also have to know what is R. R is the sample size at each level. Okay, so if let's say the sample size, the number of the data for each sample is 5, then it's 5. So the R is 5. Okay, MSE is the one that you obtain from the ANOVA table, from what you have done previously. Okay, when you calculate the SST, SSE, then MSE is what you got from SSE divided by the degree of freedom for the error. Okay, so it should be known before. And then what you have to do next is calculate the difference between each pair of the means, right? And then you have to compare the mean difference with the critical point. So what's the difference between each pair? So let's say you have all the means and you have, you put it in this way, right? So all the means for the sample. So this is from the previous example where you have these 6 samples and you calculated the mean for all the samples. So here you calculate the critical value. Okay, I just go through briefly because I have talked about this last week. Okay, I just want to get your attention on this, right? So this is the difference. This is what is meant by the difference, means that you calculate the difference between E and C and so on for all the pairs. Like E and 1.3 here is 14.6 minus 13.3, okay? And you find the difference for all the pairs and you compare with the critical value that you calculated. It depends. If you have 5%, this is the value. If it's 1%, this is a critical value. And you compare whether this one is greater or not with the 1.3. So here is 1.3 is less than 6.71. So the decision is to accept the null. Okay, this is the rule of thumb that you have to know, the rule of thumb for the comparison. Okay, so you have to make decision for each of the pair here. And what it means that if let's say those pairs that accept the null, so there is no difference between E and C, between E and control, between E and D, right? So at the end, so this one is just for you to know how to construct, how to present the data in your research. You need this kind of table with the superscript. This one should be actually a superscript. It's not in the same level. It should be like to the power of A actually, yeah. Right? So, but what is more important is that you have to know, you have to make conclusions at the end and state which pairs that have no difference, which means that you accept the null, right? And which pairs that have a difference where you reject the null. Okay, so I would prioritize this stuff because this is the most important part at the end, because we want to know which pairs that have a difference and which pairs that do not have a difference. So you must have 2 points for your conclusions and you have to list down all the pairs that you are analyzing. Okay, so that is for Tukey's test, right? Okay, before we go into today's topic, any question from the previous topic? Any question, guys? Any question? Are you still with me?
No question.
Okay, I assume you understand. Okay, thank you for your response. All right, so today's topic, we're going to go into Bonferonni method. Okay, so I mentioned just now, it is used when the sample sizes are equal or unequal, but basically it is preferred for unequal. Okay, again, sample sizes. You should understand what the terms mean in statistics. Sample sizes means the size of the sample. So for Bonferonni method is the same, is to be done after the ANOVA test, after you conclude that there is a difference or after you accept the alternative hypothesis. So in this test, what you have to do, you have to have some sort of calculation as well, whereby it has its own steps, okay? So we go through the steps first. So what are the steps? The first step is to calculate the what we call T calculated. Okay, so this is the formula. This is a formula for T calculated. There are some missing symbols over here because I use iPad and okay, let me add the symbols. Hold on. So here should be minus. Can you see my scribbles? Can, right? What I conteng on the slides.
Yes. Yes.
Okay, so this is the formula for T calculated. Okay, so this is what is meant by here is that hold on. So SP, so you got some symbols over here, XI, XJ bar. Okay, so X bar basically is average. yeah, average. And remember that same like Tukey test, you have to match every pair of all the data that you have. Okay, so xi and xj are referring to two samples that you are comparing. Okay, so let's say you have sample one, sample A, B, C, for example. So uh, you must have the average for sample A, average for sample B, and average for sample C, right? So here, and also you must have, because now we are talking about unequal sample size, so you have to expect that each of these has different, perhaps, sample size. So it has N A, and B, and B, and NC. Okay, let's say NA is 4, and B is 5, and N6 is 4 back. Okay, so it has unequal sample size. So what is meant by the symbol I and J here is referring to any two samples that you are comparing at that particular point. So if you are talking about A and B, so it means that the T, there is a T for every pair, okay? So you have to calculate, it's not only one value of T. You will come up with a number of T values depending on how many pairs you have. So for A and B, the T calculated will be, you will be using the XA, the average of A minus average of B, okay? And SP is the MSE, this is the value for SP, where MSE you got from the ANOVA table before that you have, okay? So SP is not affected. And for the values in the square root here, NI is referring to the NA, which is 4, okay? And let's say NJ is for the B, which is 1 over 5. Okay, so that's what I and J means. It means the samples that you are analyzing. So if you go for B and C, okay, after you go for A and B, or maybe A and C, yeah, A and C first, then you will change the value of the I and J. Okay, you are now referring to A and C samples, right? Okay, I hope that you understand for that. So that is the first step, whereby you have to calculate the T for every pair. And then the second step for Bonferonni method is to find critical T from T distribution table. Okay, for this one, it only has one value. It's only for the T calculated that you have many values depending on the pairs, but for the critical T, it only has one value. So how you want to find the T? So you have come across the T table before, right? So it's the same table. So how you find the critical T is based on the information here. This is the important information. So let's have a look at the T table. Do you have the T table with you? You can refer to your T table. Okay, let me open the T table. I need to open the T table. Hold on first. I need to open the T table. Can you see the elite page now? Can you see the T table on my screen?
Yes.
Okay, so this is a T table. Is the same table that you have used before for the T test, remember? So what information that you need here in order to find the T, the values given in the table here is T, okay? And you have to know what's the degree of freedom and what's the upper tail area, alpha, okay? So now the alpha value here will be a bit different, whereby you have to calculate this part, Okay, this one. The upper tail. I mean, this one is actually what you have to refer to in the table, right? The upper tail, no? This is actually the upper tail area formula. Okay, don't get confused, because you might know from any equation that you are analyzing what's the alpha value. Let's say it's 0.05, right? You don't refer that alpha value directly to the t table when you find the t critical. So you have to solve this term first. Yeah. So the upper tail area will be alpha divided by 2 times k, or 2k. Yeah? So this will be the upper tail area that you are going to refer in the t table. Okay, so if let's say your alpha is 0.05, it means that okay, what is k? K is the number of means to be compared. Okay, so if you have 3 samples, you have 3 means, right, to be compared. So it also means the number of samples. The number of samples. But yeah, it says that it's the number of means to be compared. But if you have 3 means, you have 3. If you have 3 samples, you have 3 means. So the number of means is actually equal to the number of samples. So the upper tail area is given by 0.05. Let's say you have the 3 samples, so you have to multiply 2 times 3. So the upper tail area will be given by this value. And that value, let's say in this case, is 4. This is just an example. It's not the value that you have to remember throughout any problem. So let's say here the value is 0.005 after you have solved this one. Why this one is 0.06? Oh, okay. So here, the value here is actually 0.00625. But if you refer to the table, the value, the smallest value given is 0. Let me see the table. If you see the table here, right, the most right value is 0.0005, right? So if just now the value is 0.0, 0.0, I think it's, wait, let me calculate this value. Is it 0.000? 0.006. 0.00. Oh, okay. Sorry. Let me rephrase my words just now. Okay, so if you refer to the t table, okay, 0.00, actually the value is 0.006, but the nearest value here is 0.005. Okay, so you just take the nearest value. Yeah, although you can actually, because it's very hard for you to, unless it is like the midpoint from 0.0025 and 0.005, then you can just take the middle value. But since in this case there it's not the middle value, 0.006, you just take the nearest value, which is 0.005. So that's why in this problem we take 0.005. Okay, and the degree of freedom is the degree of freedom for the error. Okay, so it's, in this case, is 16. This is, remember, this is the ANOVA table that you have to generate before you go into Bonferonni or Tukey tests. Okay, so in this case is 16, and the T critical is 2.921. Okay, so that's how you find the critical T from the T table. Okay, now, so what you have to do next, you have calculated the T for every pair. Then you have the critical T from the table. So what you have to do next is to compare every T calculated value with T critical. Okay, so now let's say in this question is it's actually the same question, the same problem like the Tukey test before. Okay, So let's say this is the samples. There are 4 samples, and it means that you have to match every pair, right? Like green and pink, green and control, green and orange, and green and orange, and then pink and orange, pink and control, pink and orange, and finally is control and orange. Okay, so I hope you know what I mean here. Green and pink, green and control, green and orange, and so on. So these are all the possible pairs that you have to match. Okay, and we know just now that we have to find out what is the T calculated for every pair. This is the T calculated, right? T calculated. And once you have that, you know what's the T critical. There's only one T critical value. Then what you have to know, what you have to do, you put all these values. Yeah, this is the T for every pair. You put like in another table, because to make it like much better and clearer. Okay, so this is all the possible pairs, and this is the mean difference. The mean difference. And this is the T calculated for each pair. Okay, so this is the T calculated. And let's say you know what's the T critical. Like let's say at 5%, you determine it from the table, like using these values of information. You got this value, right, for 5%. But if this 1%, you use this expression, because the difference will be lie in this part. So it will give different T. Yeah. So let's say 5%, let's say 5%. But in the problem later, you just have to refer to one value depending on the question. So you have to compare this value with this T, okay? And the rule of thumb is to reject the null hypothesis when the T calculated is greater than the T value, the T critical, okay? So now this one is less. So you have to, if you reject, if this one is greater, you reject. So if it is less, then you accept the null, okay? And then you have to make decision. This is actually decision, sorry. Decision. So you have to make decision for all the pairs, okay? So now this is given to you. So you accept the null hypothesis for green and pink, for pink and control, and for control and orange, whereas the rest you reject the null hypothesis. So what does it mean? It means that, okay, please hold on for the A, B, and C first. It means that when you make a conclusion, the one that have no difference is the one that accept the null hypothesis. So it means green pink, pink control, and orange pink. Okay, so you have to say here green pink, just put the initial, pink control, I guess, no? Pink control, and control orange. Okay, control orange. But in the question, in the real problem, you have to write the actual words, okay? But I just want to say here that you have to mention all the pairs under those two categories. For the GCGO, okay, this one is GCGO, and what's the other one? Pink orange, okay? Pink orange. You have to write in full for your own workout, but you have to state both conditions, which pairs that have difference, which pairs that have no difference, and which pairs that have difference. Okay, so for this A, B, and C is the same thing like the Tukey test. So how you construct this kind of lines is based on the accept null hypothesis condition. So for example, you arrange it in descending order, the mean, like 31.5 is the biggest, 26.4 is the lowest, right? So if you see this table again, the one that accept the null is green and pink, right? And pink and control, okay? And also control and orange. So if you see this table, for green and pink, you construct one line and you denote it as C, or maybe A also can. You start with A also can. And then the other line is ping and control, where you accept the null hypothesis. Okay, you draw another line B. Okay, and the other line is control and arrange. You put as A. Okay, so based on this, you can also transform into table, whereby you write the things, the mean, or the name of the hormone in this case, and you put the letter next to the mean. Okay, so I'm not really prioritizing these kind of things, but what I think is more important is that you state the conclusion, which pairs that have difference and which pairs that do not have difference. Okay, so that is Bonferonni method. Okay, let me summarize again what you have to do. It's a continuation from the ANOVA test. So having said that, you must have the ANOVA table. You must know what's the MST, MSE, yeah? Because you have reached to a conclusion that you accept the alternative hypothesis, means that there is a difference. And now when you perform the Bonferonni method, is you want to find out which pairs that have a difference. Okay, and Bonferonni is used when the sample size are equal or unequal, but it is more actually for unequal sample size, because for equal size you can use Tukey test. Okay, so what you have to do in Bonferonni, I'm just repeating what I have taught before. First, you have to calculate the T for every pair, and you have to first match how many pairs you have. Okay, you just match one by one, A, B, A, C, A, D, until the end, until you don't have any pairs to be matched more. Okay, so you have to calculate T for every pair. So this is the formula, T calculated, we call it. And this is the term. And you have to know how to use this term. So you have to have T calculated for every pair, okay? And the next thing is to find the critical T from the T distribution table, because you need to compare this T with the T calculated later. So how to use this formula? Please take note, this is very important thing. You're not going to use the alpha value directly, but you're going to use the upper tail area given by this formula, alpha divided by 2k. What is k? K is the number of means to be compared, or the number of samples, because the number of means is equal to the number of samples. Okay, so the number of samples to be compared. So this will give you the value here, where you will find from the error you got from the ANOVA table, where you have to have that before. Okay, so step 3 is to compare every T calculated with the T critical. So you have calculated the T for every pair, and you must have the value for every pair. Okay, so this is the workout that you have. So in order to be more organized, you put it in another table, whereby you just have to put like which pair and also what's the T calculated. Okay, and then you have to make decision. So the decision or the rule of thumb is that you reject a null when the T calculated is greater than the T value, the T critical, or it's the other way around. You accept the null if it is T calculated is less than the T critical. So for every pair, you make a decision whether you accept or reject the null hypothesis. Okay, so make sure you put what you accept. Okay, you can also put like alternative hypothesis, but you just have to be consistent. Okay, but I just advise you to just refer to null hypothesis, H naught. Is much easier. Okay, so you have to say what are the things that you accept. Don't just put accept, reject, because it happened. Because ANOVA is quite a long process of calculation. You might sometimes overlook such things. So at the end, you just put like accept, reject, assuming that I know what you mean, but I do not know what you mean. I do not know which hypothesis that you are referring to. So that's why you have to make sure that you put accept null hypothesis or reject alternative hypothesis. You must mention what H that you are referring to. Okay, so here you make decision for all the pairs, right, in this table. And after that, at the end, you make a conclusion. Okay, make a conclusion whereby you have to mention which pairs that have a difference and which pairs that do not have a difference. Okay, so that is Bonferonni method. So any question for Bonferonni? So that is lecture 2. Lecture 2, if you see the elite, the lecture 2 notes is up to Bonferonni, right? So we have covered Tukey tests last week. So it is also in lecture 2. Any question, guys? So perhaps you can practice more and you will get yourself familiarized with both methods. Okay, but you just have to be careful with the calculation because it's a long calculation. Is the process is long, so if your values, let's say MSE, is wrong, then it will lead to all incorrect values at the end. So please be careful. And how to be careful with your calculation? You have to be organized with your workout, label the things correctly, read the information correctly, especially when you want to know like the information like the K, the alpha, you know, when you calculate all these little things, even though it looks little, but actually it will lead you to different outcomes at the end. Okay. Any question?
Hello, doctor.
Yes.
Can I ask a question about the one now you're showing, what you're
Yes.
showing right now?
Yes.
Yes. We have this part, read you on the left side, you say got two part or this one, right?
Okay.
The upper part. This one, do we need to write it? Like do we need to show it?
Okay. So for my group, you don't have to. Okay. But you have to understand by yourself because you are going to come across these kind of things in articles. So whenever you come across in the articles A, B, and C, so you should know by yourself. Okay. Let me show you an example of article. Do I have it? Okay. Did I answer your question before I go into the article?
Yes.
Okay. So, but you have to understand what what it means. Okay. For example, like what it says here, means followed by the same letter are not significantly different. Okay. So means that let's say you have same letter like 26.4 and 27.3, both of them have A, right? So it means that they are not significantly different. They are not different because if you see back your decision here, you accept the null hypothesis. It means that there is no difference between green and pink. Okay, so does it tally with this description? That's what you have to understand. Okay. Okay. So if let's say you are analyzing the next one, control and pink have both of them have B, right? So they don't have any difference. And control and pink is the one that you accept the null hypothesis. But what happened those that have different letter? For example, A and C over here, orange and green. Orange has A and green has C. It's not equal. So in the opposite, they have different. They are significantly different. If you referring to this statement, okay, does it mean the same with your calculation or your decision over here? Orange and pink. Orange and pink. Where's orange and pink? Oh yeah, orange and pink here, right? So you reject the null hypothesis, which means that you accept the alternative hypothesis where there is a difference in between pink and orange. Okay, so that's what I mean, that you have to understand by yourself, because when you read articles and when even if you present your data, yeah, let's say you have done your research and you present your statistical data, you are going to apply these kind of things, because you want to say to people that perhaps you know, which means are different, which means are not different. But if let's say you put this one also in the exam, in your workout, is also fine, means that you understand is good. Okay, but what is important for me is that you know what you write here, which pairs do not have difference, which pairs that have difference. That's why I just emphasizing on this part of things. When you make conclusion, you just state which pairs that have difference, which pairs that do not have difference. Okay, I hope you are clear with this. And same with the Tukey methods before. It's the same thing actually. Any more question, guys?